So today in the physics we have the next chapter as center of mass and rotation motion. We will discuss few questions and some important tricks and tips. In this chapter you should note that there are very important concepts which you should apply very carefully, otherwise you will end up making mistakes. So be careful when you apply all the concepts in this chapter. Now the first question we have is, you have to find the position of center of mass for a uniform semicircular wire. This is a uniform semicircular wire. Its mass is m and the radius is r. We need to find out its center of mass of this wire, where mass is distributed uniformly along its length. So the first thing you should know about the position of center of mass is that center of mass always lies on the axis of symmetry. Now for this object, the axis of symmetry is the y-axis. Let this be x, this be y. So we already know that the center of mass lies on this axis. Now when the center of mass lies on this axis, we need not find out the x coordinate of the center of mass, because we already know the x coordinate of the center of mass to be 0. So the only thing we need to find out now is the y coordinate of the center of mass. That is, at what distance from this point is the center of mass of this semicircular wire located. Now for finding out center of mass for continuous objects, we have a formula. Y coordinate of center of mass is equal to integration dm into y upon integration dm, that is nothing else but integration dm into y upon total mass of the object. Now integration dm into y is nothing else but every small mass multiplied by its y coordinate. Every small element, every small dm mass element multiplied by its y coordinate. So in these type of questions, you have to intelligently select the dm mass element. So in these type of questions, it is always very crucial as to which small element do you choose. So in these type of questions, there is a standard way which I am going to tell you now. You take angle theta, and at any general angle theta, you take an element which is subtending an angle d theta. This angle is d theta. This d theta is very small. So our small element is this one, which is subtending an angle of d theta, and it is located at a position of angle theta. Now we also want to find out the mass of this element, because you have to write dm. So for that, we can write the mass per unit length of the semicircular ring as lambda. Lambda is the mass per unit length of the semicircular wire. So lambda is equal to mass upon pi r. We know the arc length of this element, that is equal to r d theta. So we actually know the length of this small element. Now the length of this small element multiplied by mass per unit length will give us the mass of the small element. So we can write dm is equal to lambda into r d theta. This is equal to m upon pi r into r d theta. This is equal to m into d theta upon pi. Now we know our small mass element dm is equal to m d theta upon pi. What we now need to find out is the y coordinate of this corresponding dm mass element. Now for this dm mass element, the y coordinate is this length is r, this is r cos theta, therefore this is r sin theta. Therefore we know the y coordinate of this element to be r sin theta. Now we integrate this, integration dmy upon m, this is equal to integration r sin theta into m d theta upon pi upon m, that is the total mass of the semicircular wire. Now we need to integrate this such that we cover all the mass using these dm elements. So if we vary theta from 0 to pi, we will be able to cover this whole mass m by using small dm masses. So we put the limits of integration over here to be 0 to pi. So while solving this integration, we'll get the final answer. Y coordinate of center of mass is equal to mr upon pi divided by m gets cancelled, integration 0 to pi sin theta d theta. Now sin theta, graph of sin theta is like this. This area is equal to 2 from 0 to pi. Therefore integration 0 to pi sin theta d theta is equal to 2. Therefore we get the y coordinate to be 2r upon pi. So we can now say that for a semicircular wire, for a uniform semicircular wire, the position of center of mass is at a distance of 2r upon pi above the center of the semicircular wire, and the x coordinate is 0. If we assume this to be 0, 0. So the x coordinates of the center of mass come out to be 0, 2r upon pi. So you should also remember this result, that the center of mass of a semicircular wire is located at a distance of 2r upon pi above the center of the semicircular wire.